Good morning, and let us attempt to solve today's problem. So, today's problem is saying that if you have been given a string like this, it is only good if the frequency of each character in the string does not repeat. And so, for the first example, we see that A appears twice and B appears once. And so, because the frequencies do not repeat, we have two, we have one, it can be considered as a good character. But if we look at the second example, we have A, which appears three times, B, which also appears three times, and C, which appears twice. So we have three, three, and two. Can we consider this as a good string? No, because two of the elements appear the same. And so what he is saying is that if there is ever such repetitions, what we have to do is to reduce one of these things, right? So if we reduce one of the three, say we reduce the first one to a two, is it now a good string? No, because we still have two here. So if we reduce this one to a one, is it now a good string? Yes, because this is one which is unique, three which is unique, and two which is unique. And so they are asking us how many of these deletions do we need to make in order to get the string to be good or whatever. And so how I approached this was to use a hash map. But I didn't really use a hash map because we are using um because the letters are going to be smaller case English letters. I just used an array of 26 characters. So the first element will be, 0, and the last will be Z, right? And so in there, I put in the number of occurrences of A, which is 3, then the number of occurrences of B, which is also 3, then the number of occurrences of C, which is also 3, right? After doing this, we will basically sort this frequency map, right? We're going to sort it, and then we will now how do I say this? After sorting it, we will now attempt to append these elements, right? The elements into some sort of a fictitious stack. So we are going to sort this array in the descending order, right? The reason why like we are sorting it in the descending order will make a whole lot of sense later, but let us start. So after sorting it in the descending order, this one luckily for us is already in the descending order. We will have this fictitious stack in which we are going to append these numbers to. So on first we are going to append 3 because the stack is empty. Now when we come to append this 3, we will check the last element in the stack. The last element is it is the same as this number, right? And so we are going to reduce this guy by 1. So that means that we've made one deletion. Then when we come to append 2, we will see that okay, 2 is also the same as the last number, and so we are going to reduce it to 1. And so that means that we've made 2 deletions, and that will be our final answer. And so these are basically the steps that we are going to take to arrive at our answer. We will first get our frequencies. So you could use a hash map or something. Then you will sort the values of the hash map in descending order, and then we will apply this stack logic to it, right? So there are a few edge cases that we need to take in mind. Take for instance, if we had say a D here, right? So and then maybe we had an E here. How would this have been different? So if we had say C D D E, so now we now have three. Sorry, we would have had 3 3 2. This is listen, 3 3 2 2 and then 1, and then we would have done the exact same thing, right? So like we added a 3, we added this 3 but we reduced it to 1, we added this 2 but we reduced it to 1. We are now about to add this guy, but because this one is greater than, or you know but because this 2 is greater than this one, we are going to add the smallest distance, right? So we are going to delete everything. The moment we hit 0 here, whatever is remaining, we don't really need to consider it again since we cannot add it, right? Even like the same thing can even like we can even do it from here. Like the moment we see that the last element in our stack is 1, whatever is remaining, we don't really need to even add it again. We can just delete them outright. And so we like if we delete all of this outright, then this one now is no longer 2, it is now 5, since we made these deletions as well, these 1 2 3 deletions, and so let us review it all over again. We started by creating like the hash map and then sorting the frequencies of the elements in the descending order, and then we started to append them to a stack, right? So at first the stack was empty, so we added 3. When we are about to add this 3, we checked the last element to see if this one was greater than or equal to it. If it was, then we make sure that we we reduce it to one less of this guy, and like however many like deletions that we made from it, you know so like here we made one deletion in order to get it to be one less than this guy, and then the exact same thing happened here. We are about to add this 2. We checked 2 is greater than or equal to this one, and so we reduced it to a 1. The moment we hit a 1, we know that any other thing that we need to add has to be completely like deleted, and so we just delete them and just add them right to the answer. And so that is a solution to the problem. So let us get to the code. I have already written the code, so I wrote it early in the morning, like once I woke up, so like 5 hours ago. So this is it. So this is us creating the hash map. This is we sorting the map in the descending order, and like we don't really need a stack per se, since like we just need to keep track of only like the last element. So instead of having a stack, I just use an integer that kept track of the last element. And so yeah, we kept track of the last element, and if and so this was what I was saying. If the last element was 3, no, if the last element in our stack was um, um was 1, then basically we just um, deleted all the elements outright. And if the number was greater than or equal to the last element in our stack, we did that stuff that we discussed. And yeah, if it is not, we set that one to the last element, and that was it. And this solution worked pretty well. And so yeah, that is the solution to today's problem. See you tomorrow.